What you are seeing emerging from this furnace is molten steel. The steel is heated to around 1700 degrees centigrade to eliminate as many impurities as possible. Then the components are adjusted to form high-carbon chromium-bearing steel, an extremely rigid, high-tensile bearing material. The blocks of scoured high-carbon chromium steel are then formed into the sizes and shapes necessary to facilitate the subsequent processes for various bearings. This is the rolling process. In this way, bearing material is molded into wires, plates, pipes, and bars, and sent on to production plants. Bearings typically consist of an outer ring, which is set in a housing, an inner ring set in a rolling axle, a rolling element that fits between the two, and retainers that prevent the rolling elements from falling out or contacting one another. Moving a little closer, you can see the side surfaces, the exterior or outer surface, the raceway, the surface on which the elements roll, and the inside diameter or bore. Rolling elements can be either ball or cylindrical type. Bearings with ball-type rollers are known as ball bearings. Those with cylindrical rollers are roller bearings. Nachi presently manufactures more than 5,000 types of bearings. Let's follow the manufacturing process for the most common type, deep groove ball bearings. We begin with the making of the inner and outer rings. The bar is first heated by a coil, then cut. Next, it is pressed by machine and molded into outer and inner ring shapes, which are then separated. The designated shapes are formed by hot forging. The next step is the turning of the rings. This is the turning process for the inner ring. First, one side surface is cut, then the other. After that, the bore is cut. Then comes chamfering. Finally, the ball raceway is cut, and the turning of the inner rings is completed. The turning of the outer rings follows a similar process. When specified, marks are stamped to indicate the bearing type, after which the rings are sent to the next process. Now we've come to the third process, heat treatment. Because the inner and outer rings function under tremendous pressure, and because they are repeatedly applied through rolling motions, they must be extremely rigid and resistant to wear. To boost their rigidity, they undergo a process called quenching, in which they are heated to between 800 and 850 degrees centigrade, then instantly cooled. To boost wear resistance, they are held at 150 to 200 degrees for a period, then cooled slowly in a process called tempering. Next comes the fourth of the 5 steps, grinding. We begin with the outer ring. The ring's side surface is first ground to serve as a reference for subsequent grinding. Next, the outer surface is ground so that it is precisely 90 degrees to the side surface. Then, using the outer surface as reference, a raceway groove is honed on the bore side. The inner ring also undergoes grinding. Now let's see how the rolling elements are made. To start, steel wires are die cut into balls. The balls are then filed smooth by continuously rolling them on a board. After undergoing heat treatment, they are repeatedly polished with a grindstone to a mirror-like shine. Then, after each is determined to be spherically precise, they are sorted by diameter to within plus minus 1/1000th of a millimeter and delivered to various assembly plants. Next comes the making of the retainers. Retainers for deep groove ball bearings are typically manufactured by press molding steel plates. Now for assembly and quality assurance inspections. There are slight gaps between the inner and outer rings and the ball and the roller. This is what is known as the internal clearance, a specification that varies according to the bearing's application. When a bearing is being assembled, the internal clearance is adjusted by selecting balls and rollers of different sizes. To give you a better idea, let's watch industrial robots assemble deep groove ball bearings. Here the machine is measuring the raceway dimensions of a matched pair of inner and outer rings. That measurement determines which ball size is chosen. The machine then places the correct number of balls between the inner and outer rings. Retainers are placed above and below, and the assembled units are cleaned. At this point, grease is applied, and the bearing is sealed tight. Every Nachi bearing now has to pass a series of graduation tests before they are shipped out. Precision must meet or exceed design criteria. Durability has to be exceptional. Performance must exhibit exacting uniformity. The noise levels must fall within prescribed standards. Nothing is overlooked to assure the highest standards of quality and reliability. A vertically integrated production process that starts with the raw material. Thorough quality assurance. Consummate know-how and expertise, a wealth of experience. All this and more go into the making of every Nachi bearing we send out to the world. At Nachi, only the best is good enough.